In 1997, when IDEA was authorized, fewer than 10% of the studies with students with severe disabilities focused on any sort of academic skill. At least 10 studies have indicated that students with severe intellectual disabilities can learn math skills, especially in the area of time and in money. In 2008, Browder and colleagues conducted a comprehensive review of the research to teach math to students with significant cognitive disabilities. Each component of mathematics defined by the National Council for Teachers of Mathematics was addressed: numbers and operations, measurement, algebra, geometry, and data analysis. As you can see here in this graph, very few research was found in the area of algebra, geometry, or data analysis. Actually, in looking closer at each one of these areas, other is used to indicate that while the skill might have addressed informally algebra, it may not have been a very close link with the skills that the National Council for Teachers of Mathematics defined as algebra. Maybe something with patterns in a home living activity could have been done in algebra, where it did have a link to algebra, but it might have been a fairly weak link. In the areas of numbers and operations, you can see that majority of the research was found in there, with an overwhelming amount of research found in the area of money and some in time. So what we can tell from this, and looking at the research that was conducted, that was reviewed, from 1975 to 2005, is that the majority of research that has been conducted is in the area of money, and maybe some in numbers and operations when it might have something to do with number identification, rote counting skills. So we know that these are areas that are very important for students with significant cognitive disabilities. But the research is there. The research shows us how, and this is something that we do know how to teach as a field for students with severe disabilities. But this also shows us that there's a lot more to do with teaching math, and we need to look at research that needs to be conducted in the areas of algebra, geometry, and data analysis to help us build a strong foundation, an evidence-based foundation, in how to teach these areas and these components of math. The National Council for Teachers of Mathematics has defined 5 content standards that all teachers should teach from. Each standard is defined, and they have provided teachers with the big ideas of math. These big ideas are important to know as a teacher of mathematics. They provide us with the essential skills that all students should be taught. Majority of state standards are defined around the 5 content standards. For example, in North Carolina, each grade level will have a standard in algebra, one in measurement, one in geometry, and so on. While many state standards and objectives will address multiple NCTM standards, it's important to understand the big idea or big picture of each of these standards to assure that we know what the overall objective is in geometry or algebra. Let's take a few minutes to review each one of these standards and gain a clear picture of what each means in the world of math. Numbers and operations is the first of the standards. The National Council for Teachers of Mathematics suggests that students pre-kindergarten all the way through grade 12 should be able to, or should be taught to understand numbers, ways of representing numbers, relationships, understanding the meanings of operations and how they relate to each other, and be able to compute fluently to make reasonable estimations. Numbers and operations is one standard that typically you will find embedded within multiple other standards. For example, understanding numbers and maybe ways of representing numbers is something that you would find within measurement or within algebra. So numbers and operations is not something that is always completely separate as a standard. It's something that you will find embedded in other standards. However, in early grades, numbers and operations can be found alone in some of the standards to build some of those prerequisite skills to being able to compute or make reasonable estimates. Algebra is the second of the 5 standards. The National Council for Teachers of Mathematics, or NCTM, suggests that all students should be able to understand patterns, relations, and functions, use algebraic symbols, and use mathematical models to represent and understand relationships. Algebra is not a standard in math that's only taught to secondary level students. If you look at your state standards, you'll find that students are being taught problem-solving skills to use algebra as early as pre-kindergarten. Understanding this standard will help make algebra something that can be taught to students with significant intellectual disabilities easier for us as teachers of special education. Geometry is the third of the 5 standards. One misconception some teachers have of geometry is that shape identification is the big idea of the standard. If you look at the objectives listed on the slide, you'll notice that identification of shapes is not even listed. Geometry is the study of spatial relationships. Students are taught to analyze characteristics of shapes, develop relationships among them. Students are taught to describe spatial relationships using coordinates and apply and analyze symmetry to solve problems. Do you notice something all these standards have in common? Problem solving. Maybe that's the big idea of math. Let's look at the next standard and see what it is all about. Measurement is the 4th standard defined by the National Council for Teachers of Mathematics. NCTM suggests that all students should be taught to understand and measure attributes of objects. They specifically talk about the use of techniques, tools, and formulas to determine or problem solve measurement. Can you remember slide 3 of this PowerPoint with the graph of all the studies reviewed in the comprehensive literature review that Dr. Browder and colleagues conducted? This is the area of math where majority of the research that they found was conducted. An overwhelming amount of that research was in the area of money. While this is a very, very important skill to teach all students, especially those with significant intellectual disabilities, we know that there are many more skills that should be taught within this standard of measurement. All right, we're almost done. Now let's take a look at the last of the 5 content standards for math. Okay, we're finally at the last of the 5 standards, data analysis and probability. While the research from Dr. Browder and colleagues did not show a large amount of research in this area of math, many teachers are familiar with teaching students to use bar graphs within their daily activities. But pay special attention to the objectives that the National Council for Teachers of Mathematics, NCTM, expect all students to be taught. Many of these build on the idea of problem solving in math. There it is again, problem solving. Students are expected to formulate questions that can be addressed within the data. Students are expected to collect and analyze that data to answer questions. Inferences and predictions are also to be made based on the data. Students build their understanding of probability within the standard as well. Data analysis is so much more than bar graphs in a classroom to chart who likes a specific snack or what book to read during group time. The big idea of data analysis is problem solving and using that data to solve problems. Now that we know about each of the 5 standards, we need to think about how do we really make math accessible to our students. First of all, we need to focus on instruction of the big ideas. For example, in geometry, our instruction needs to focus on special organizational skills. Specifically, in middle school, students spend majority of their time learning about a coordinate plane and using them to solve problems. So a student with a significant intellectual disability in middle school should be learning about coordinate planes and maybe using an activity using a neighborhood map. That would be a great way to make this skill personally relevant and a personally relevant activity linked to the state standards. Next, manipulatives are a great way to help students make connections. If learning about how to solve a problem that involves needing more cups for a snack, use the actual cups to build meaning of the symbols used in that lesson. Next, we want to relate math to real-life activities. This is one of the best strategies to help all students learn math. Every math skill that is taught has a function. We all use math every day to solve problems. If we can relate these math skills to something that's meaningful and personally relevant to the students, we can create learning that is not only useful, but fun and motivating as well. Finally, we want to base our instruction on evidence-based strategies. As we progress through this module, we'll discuss various different forms of systematic instruction procedures that are evidence-based practices, such as time delay and task analytic instruction. Problem solving is the main idea of math. All students use math to solve daily problems. The National Council for Teachers of Mathematics specifically notes that problem solving should be taught through the 5 content standards. Self-determination skills are something that the field of special education have valued for students with disabilities for years. The ability to independently problem solve is something useful and personally relevant for all students. Think back to Latia and her teacher, Miss Wilson. Miss Wilson teaches her students under the idea of least dangerous assumption. Doing this assures Latia access to all of these math standards while building her independence to problem solve her own life problems, something she can use for the rest of her life, during school, in the community, and after school, in her job, in her community activities, and whatever recreational activities she chooses to do.